Hello students, as you people observing on screen, today we are going to discuss about change of state. Change of state due to absorption of heat energy. So let's start today's topic. Now, as we know that when heat energy is absorbed or given out by a substance, in addition to rise or fall in temperature or change in dimension of its substance, its state may also change. For example, if we see on board, if we have a liquid, clear, heat energy is given to this liquid, what happened? Liquid changes to gaseous form. This is plus heat energy, clear? And whenever heat energy taken from the gas, from this gas, means minus heat is there, gas converts itself into liquid. This is a change of state by absorbing heat energy. Similarly, in this case, suppose we have a solid. When heat energy given to solid, it changes to liquid, and whenever heat energy is taken from liquid, it changes to solid. Hope this one is clear. Again, in case of some particular substance, whenever we give heat energy to solid, they not come to liquid or gas, say directly pass to the gaseous form, and gas condenses to the solid form when heat is taken. So this is a type of cycle run when we absorb heat energy or given heat energy. We start from solid. When in case of solid we give heat energy to solid, solid changes to liquid, and again when liquid further more heated, it temperature increases and it converts itself into gas. And if we run the opposite thing, means from gas, if we absorb heat energy minus heat energy, gas condenses to liquid, and further liquid condenses to solid. There are some conditions for some substances whenever solid heated, they never pass to liquid, they directly changes itself into gas. This is another type of change of state. So one by one we discuss about type of change of state in this video. Now our new topic is change of state of solid to liquid on the basis of change of state from solid to liquid on the basis of kinetic theory. Kinetic theory. All of you listen this very carefully. As we know that in case of any state of matter, molecules are in continuous motion. Molecules or particles are in continuous motion. This is a basic theory. Whenever heat energy is given to this solid, molecules increase their movement, they vibrate more about their mean position. During this vibration, molecules collide with each other. When molecules absorb heat energy, they increase their movement and they collide with each other to make more space. To make more space. So, by absorbing heat energy, sorry, molecules increase their movement. By increasing their movement, molecules collide with each other to make more and more space. By doing so, they move away from each other, and at last, at point there is a condition comes into picture when there is a intermolecular space is more than the previous condition. Space is more. So in solid expand itself and intermolecular space is more, so solid converts into liquid, gradually absorbing the heat energy. Hope this one is clear. Once again I am repeating this theory. When a solid is heated, its molecules absorb heat energy. As we know from the kinetic theory, molecules are in continuous motion. In case of solid, molecules vibrate about their mean position. But when these molecules absorb heat energy from outsides, these molecules start to increase their vibration. During this improvement of vibration, increasing of speed, they collide with each other to make some space. During collision, they collide with each other to make more and more space available for them. Due to this, intermolecular space is increases, and as intermolecular space increases, intermolecular force of attraction weakens down itself. So solid changes to at last solid changes to liquid. This is the kinetic theory of matter. This change in state from solid to liquid is known as your melting point. All of you must remember the change in state from solid to liquid is called melting or fusion, and temperature at which this happen is called melting point. So hope this concept is clear to you. Same concept for liquid to gas. Now similarly we are going to discuss about liquid to gas on the basis of kinetic theory. As we know that in case of liquid, they interchange their position. They're able to interchange their their position because there is a moderate amount of intermolecular space and moderate amount of intermolecular force of attraction. Now whenever liquid absorb heat energy, molecules try to interchange their position more vigorously. By doing this, they overcome the intermolecular force of attraction. Intermolecular force, and after some time condition occur that they move away from each other. This type of condition, when comes, liquid molecules change their state from liquid to gas. Once again I am repeating, see very carefully. Whenever we heat liquid particles As we know that liquid molecules are able to interchange their position within their boundary, but when they receive heat energy, what happens? They interchange their position more vigorously, such that they come at a condition that they overcome the intermolecular force of attraction. They move away their limit, and by doing this the liquid changes to gaseous state by absorbing heat energy. This is the basic concept of change of state from liquid to gas on the basis of kinetic theory. Now, from the book or any other thing, it is clearly written that when a liquid is heated, its molecule absorb heat energy and thus their kinetic energy start increasing. This thing happen in both the cases, whether it's a solid or liquid. As the average kinetic energy of the molecules continues increasing, therefore the temperature of the liquid rises. Furthermore, with the increase in the kinetic energy, the molecules vibrate with a greater amplitude about their mean position. This in turn increases the intermolecular space and weakens the intermolecular force of attraction. This continues till the kinetic energy of the molecules becomes more than the intermolecular forces. At this stage, the energetic molecules rapidly leave the liquid and changes into gaseous state. More or less, they are saying the same thing. They are saying that whenever we increase the heat energy, the molecules start to interchange their position more vigorously, and after some time they overcome the internal force of attraction and they convert themselves liquid to gas. So this is the concept. All of you once read from the book so that you can easily clear the concept. Hello students. Now in this case we are discussing some interesting thing. If we have some ice in a container and we insert a thermometer in the container and supply heat energy to that container, what we observe? Ice first increases its temperature. By seeing the thermometer, we observe that previously temperature of ice is minus 10 degrees centigrade. When we start to heat the container, temperature reaches at 0 degrees centigrade, from minus 10 degrees centigrade to 0 degrees centigrade. And at this temperature, when we supply more heat energy, what we observe? That temperature remains fixed, but ice start to melt to water at 0 degree centigrade. 0 degree centigrade. Then if we increase the heat further, so water start to heat increase its temperature. This thing observe, primarily basically these thing observe. If we see at this temperature at 0 degree centigrade, first we have ice, then by supplying more heat energy, this ice changes to water by keeping the temperature constant. So in this case we can say that the amount of heat energy supplied to a solid at its melting point such that it changes into liquid state without any rise in temperature, this extra amount of heat of energy is known as your latent heat of fusion. It is known as your latent heat of fusion. What does it mean? Remember that extra amount of heat energy supplied to ice at 0 degree centigrade so that ice or solid converts itself into liquid at same temperature. That extra amount of heat energy is known as your latent heat of fusion. Or specifically, if we say that the amount of heat energy required to change 1 kilogram ice at 0 degree centigrade to 1 kilogram water at 0 degree centigrade. This is special amount of heat is known as your specific latent heat of fusion of ice. Remember, its experimental value is 336 joule per gram. 336 joule per gram means for now if we increase this amount of heat further, condition occur that water reaches up to 100 degrees centigrade. Clear? At this temperature, if we increase further, water converts itself into steam at 100 degrees centigrade. Hope you are able to see this last line. Oh, it's not visible. See, if we increase this heat further, so from water at 10 degrees centigrade, it reaches water at 100 degrees centigrade. If we further supply heat energy, what happen? Steam, we observe steam at 100 degrees centigrade. Means at this condition, when water liquid changes to gaseous state without any rise in temperature, this type of heat is known as latent heat of vaporization. Latent heat of vaporization. And if we define by specifically with some unique mass like previous condition, if we the amount of heat energy required to change 1 kilogram water at 100 degrees centigrade to 1 kilogram steam at 100 degrees centigrade at 100 degrees centigrade is known as your specific latent heat of vaporization, and its value is 2260 joule per gram. So this is the latent heat of vaporization, and this is the reason we burn more severely than steam as compared to the hot boiling water, because hot water or boiling water never contain this amount of energy. When we give this extra amount of heat energy to boiling water converts itself into steam at 100 degrees centigrade. So always remember, in case of solid to liquid, liquid has more temperature at the same degree, at same temperature liquid has more heat energy. Similarly, in this condition, as compared to boiling water or steam has more heat energy as compared to the boiling water. So this is the concept of change in state and some basic terms. Now in by using these specific latent heat of vaporization or latent heat of fusion, we have different natural consequences. That soft drink bottles cool better in ice than water at 100 degrees centigrade. Why? Because ice does not contain extra amount of heat, that is your 336 joule per gram, but water at the same temperature contain 336 joule more than the ice. That it is the reason that any bottle cool more in ice as compared to water at same temperature. So hope this concept is clear to you. Now all of you see the book and read all the definitions given in your book, because it is not possible to explain each and every definitions in video, but once you are able to read these points, you are able to understand. So that's all for this video. Thank you.